Well, welcome to section 3.3, which is multiplication with fractions. And this is where now you're going to have to start to think and not just process. And we're going to use our number lines to visualize what's going on. But there's some tricky stuff in here which is not bad if you think it through. So make sure you read the book first and then watch this video. So here in example 3.21a, our first one, it says that your gas tank in your car holds 12 gallons of gas, and the gas gauge reads 3/4 full. So how many gallons of gas are in your gas tank? Now, hopefully, one thing I want you to understand here is that the result, right, the answer is going to be less than 12. Why is it less than 12? Because it's less than 4/4 or the whole filled, okay? So we're going to create number lines for the tank, for gallons, and for force, because we have 3/4, so we're going to use force. And when we when the word of appears, right? How many gallons of gas are in your gas tank? Well, we want 3/4 of 12. And that's going to involve both multiplying and dividing, as we're going to see. So let's do our number lines. This will be our tank. There's one whole tank. These will be gallons. There's 12 gallons in a tank. And this will be 4/4, because there's 4/4 in a whole. And I'm going to put in the other fourths: 1/4, 2/4, 3/4, 4/4, and I'm going to find how many gallons are in each one. All right, there's 12 gallons in a tank of gas. One tank is 12 gallons, which is the same as 4/4, right? So what I'm going to do here is take 12 and divide it by 4. That'll give me, that's the same as taking 1/4 of 12. And by do that, I'm going to get 3 gallons. So there's 3 gallons in 1/4. So if I triple the amount of force, I would triple the amount of gallons, and I'm going to get 9 gallons in 3/4. Now here's mathematics. So I wound up dividing to find 1/4 and then multiplying to find 3/4. Here's how you could do it in one expression. I want 3/4 of 12. Now recognize that this 12 is in the numerator. I usually don't do this and put a 1 under it, but I will for this case. So I can go 12 divided by 4 is 3, and 3 times 3 is 9. So there, in one expression, I can find out what what part of the whole we have with 3/4 of a tank. So here's a thought question. And it says 1 bushel of apples weighs 48 pounds. How much does 3/8 of a bushel of apples weigh? And I'm going to do this in one expression. So of is really a standard English word for multiply. So here I want 3/8 of 48. Recognize clearly that when I'm taking less than 8/8, I'm going to get less than 48 pounds. If I take 7/8, I'm going to get less than 48 pounds. I'm taking 3/8, so I'm going to get less than 48 pounds. And when you multiply a fraction times a whole number, what you're going to wind up doing is dividing and then multiplying. Because it's easier to divide first and then multiply. I know that you have, remember that, please excuse my dear Aunt Sally, that mnemonic for the order of operations. Well, my and dear, which is multiply and divide, are on the same level. So you have a choice of doing either one first. Recognize that that's that. So I can take 48, divide it by 8, and get 6, and then take 6 times 3 and get 18 pounds. So here we have a fraction times a fraction, right, of meaning multiply. So this is 2/5 times 25/12. And I could write it like this. I'm going to build up to other ways of doing it, but this is how we're going to start, right? So twelfths can be thought of as the same as gallons or pounds. 2/5 of 25 of these. So I can simply go 2/5 times 25/12. And here I can divide first. 25 divided by 5 is 5, and 5 times 2 is 10. So the answer is 10/12. I can write it like this, and then I could reduce it, right, by finding a common factor, which we know 2 is a common factor. So that can be written as 2 times 5, and this can be written as 2 times 6. 2 divided by 2 is 1. So the reduced answer you can write as 5/6. Or you can write it this way, 5/6. Okay, so there's a few things going on in this problem. In this problem, you have 2/3 of a container of yogurt. So here's the 2/3 of the container of yogurt. And you want to divide it evenly into fourths for 4 servings. How large will each serving be? Now recall that 8, for instance, divided by 4 is the same thing as 1/4 times 8. So that's just sort of an aside to get you to realize that we've done this before, right? So instead of doing 2/3 divided by 4, or 2/3 divided evenly into 4 people, we're going to take 1/4 of 2/3. Because 1/4 times 2/3 is the same as 2/3 divided by 4. It goes back to what we've already explored here in previous chapters. So we want 1/3 of 1/4 of 2/3, which we can also write like this. Now, in our previous problems, we had like 2/3 of 12/7. And 12 divided nicely into 3, and I got 4. 4 times 2 is 8, so the answer was 8/7. And the other one that was in the book that we just did was we want 2/5 of 25/12. 25 divided nicely. 25 divided by 5 gave us a nice whole number of 5. And 5 times 2 is 10. And we got 10/12. which we reduced to 5/6. Now in this problem, if I want 1/4 of 2/3, I don't know what that is. It doesn't fall evenly on this number line. So notice that 2 divided by 4 is not a very nice number. It's a decimal or a fraction. It's not a nice whole number, right? So I'm going to change the 2 here into a 4 so that it divides evenly. So I have 2/3, and I'm going to change the top number into a 4, so what would be the bottom number? And if you guess 6, you would be correct. So 2/3 is the same, it's equivalent to 4/6. It's the same number. So I'm going to change these into sixths. Six, six. And let's see what we get. So I have 2/3. I want 1/4 of 4/6. 4 divided by 4 is 1. 1 times 1 is 1. So let me write it this way. 1/4 of 4/6. 4 divided by 4 is 1. 1 times 1 is 1. So this number here is 1/6. I'm going to go up to the top here. 1/6. So 1/4 of 2/3 is 1/6. So example 3.24a, you have 2/3 of a container of yogurt and you want to put 3/4 of it into your lunch. How much of the container goes into your lunch? So I'm going to do this with the units. So I have 2/3 of times 3/4. Which you could also write, and you will write like that. Remember, with multiplication and division, the units multiply, right? Well, with the addition and subtraction, you cannot add or subtract different units. So I could not add these two without changing one or both of the fractions. But with multiplication, they simply multiply. So I could just go 2 times 3 is 6. Thirds times fourths is 12. And I get a new unit through multiplication. So 6/12 can be reduced. 6 times 1 is 6. 6 times 2 is 12. The 6 cancel and it reduces to 1/2. So if you have 2/3 of a container of yogurt and you want to put 3/4 of it into your lunch, you're actually going to wind up with 1/2 of the container in your lunch. So we're just going to review a little bit. Going back to this problem, we had to find 1/4 of 2/3. And we changed the 2/3 into 4/6. So 1/4 of 4/6. And I can rewrite it, of course, like this: 1/4 of 4/6. The 4's cancel because 4 divided by 4 is 1, and I get 1 times 1, which is 1/6. So that was the answer. Now it looks like if I just did 1/4 of 4/6. Or the 4s would cancel and I get 1/6. So let's do 1/4 of 2/3. And if I multiply straight across, I would get 2/12. But 2/12 were reduced to 1/6. So it looks like the shortcut here is going to be just multiplying the numerators and then multiplying the denominators. Or if you want, you can reduce first, right? And then for this one that we just did, we really have 2/3 times 3/4. And really, we just wound up multiplying the numerators and then multiplying the denominators. So there is a shortcut. The shortcut to what we've been doing is simply the rule of how to multiply fractions. You multiply straight across. So the examples in the book and the examples that we went over highlight a mathematical shortcut for multiplying fractions. You multiply the numerators and then you multiply the denominators. So here is the rule. When multiplying fractions, simply multiply straight across. If you have a fraction a over b times a fraction c over d, it's going to be the result, the product, the answer is a times c divided by b times d. So hopefully you read 3.25. This is 3.25a. So it says you need hay for your alpacas. A trailer contains 14 bales of hay and it's 2/3 full. How many bales of hay does the trailer hold when it is full? So I'm going to create number lines here for the trailer. For the bales of hay, let's write bales, and for thirds, because that's what we have here. And I'm going to divide and multiply in order to answer the question. So here is the first one. Whoops, that's not good. Here is our straight line trailer, one trailer. And here is our bales of hay. I don't know how many bales of hay is contained in one trailer. And here is thirds. So I got 1/3, 2/3, and 3/3. So the only other bit of information I have is right here. 2/3 is 14 bales. And I'm trying to find out how many bales in the entire trailer, right? So this would be 1/3 of the trailer, 2/3 of the trailer, and finally the whole trailer. So ask yourself, are there 14 bales the whole or part of the whole, right? And they are part of the whole, they're not the whole. So I'm going to need more bales. This is going to be a larger number here than what we have here. So how am I going to do this? So I'm going to take the 14 bales and divide it by 2. And I get 7 bales right here, which is going to be 1/3, right? If 2/3 is 14, divide 2 by 2, I get 1/3. Divide 14 by 2, I get 7. So I can divide it by 2 and then multiply by 3. 1/3 times 3 is 3/3. 7 times 3 is 21. This really helps to have some kind of visualization of a problem like this. A lot of students, they get very confused on these. So really what I did in one expression, I took 14 bales and I divided it by 2 and then multiplied it by 3. 14 divided by 2 multiplied by 3. And I got 21. So there it is in one expression. Notice that 3 halves, the relationship between 3 halves and 2/3. Notice 3 halves is greater than 1. So I took 14, multiplied it by a number greater than 1, I'm going to get a number bigger than 14. Where in the other problems, I multiplied it by a number less than 1, and I got less than my original number. So remember from the last problem, I had 14 bales of hay, and I wanted 2/3 of this. This is 2/3 of the trailer, I mean. So I wound up multiplying by 3 halves. And 2/3 and 3 halves are called reciprocals because when you multiply them together, and you multiply straight across, right, you get 1. So a reciprocal is the number that when you multiply this by, you'll get 1. So the reciprocal of 4/5 is 5/4, because when you multiply them straight across, you get 1. The reciprocal of a negative 7/10 is a negative 10/7, because when you multiply those straight across, a negative times a negative is a positive, right? You get 70 over 70, which again is 1. And the reciprocal of a negative 8, recall negative 8 can be written as negative 8 over 1, is negative 1/8. Again, a negative times a negative is a positive, and you'll get 8 over 8, which is 1. So we use these reciprocals a lot. And that's what they are. Okay, so I'm going to go ahead and solve these two problems. So I have a negative 5/6 times x equals 7. Now this is a problem here, right? We've had problems like this, like 3x equals 9, for example. We divided both sides by 3. But dividing here by a negative 5/6 seems a little confusing because I'm going to have to divide over here by a negative 5/6. So along comes the reciprocal, negative 6/5. So if I multiply that side by a negative 6/5, I can multiply this side by a negative 6/5. So 6/5 times 5/6, negative times a negative is a positive. So these just cancel because it's 1, and I'm left with x on this side. And on this side, you have to be able to multiply these. I might want to put a 1 under there, and then you can multiply straight across. And a positive times a negative is a negative. And 5 times 1 is 5. You want to make it into a mixed number. It's going to be a negative 8, and then I'll use up 40 of them, and I got 2/5 left. Okay, so now let's try this one. 7/10 times x plus 3 equals 5. Now, I don't want to I could multiply by 7/10, but then I'd have to multiply this by 7/10 and this by 7/10. And that's going to be too much work. So the easiest thing to do is to get rid of the 3 first by subtracting 3 from both sides. And then I get 7/10 times x, 3 minus 3 is 0, equals 2. Now I can multiply both sides by 10/7. Multiply that by 10/7, Multiply that by 10/7. These cancel because that's the reciprocal. And I get x equals, and I can multiply these straight across, 20/7, which is good enough, but as a mixed number, that is 2 6/7. So these are some of the homework problems I picked to go over. So this one here, it says the gauge on your propane tank reads 40% or 2/5 full. 40%, which we're not getting into until next chapter, means 40/100, which that's 4 times 10, and that's 10 times 10. 10/10 is 1, so I'm left with 4/10, and that's a common factor of 2, so I can write that and write that like that. 10 is 5 times 2, 2/2 cancels, so 40% is 2/5. I just showed you how you can go about checking it. So here I have fifths up here in one tank, and it holds 500 gallons, one tank. So I'm looking for 2/5 of it, so I want this here. Probably the easiest way to get 2/5 is to take 500 gallons, divide it by 5, I get 100 gallons, and then multiply it by 2, I get 200 gallons. In one expression, that's 2/5 times 500. 500 divided by 5 is 100. 100 times 2 is 200. So this problem states that, this is problem number 5, you have $250 in your savings account after you took out 1/3 of your money. How much money was in your savings account before you took the money out? Well, notice I made number lines for a savings account, for dollars, and for thirds, because I had thirds here. It gave me dollars up here and a savings account. So if I took out 1/3, I would have 2/3 left. So 250 represents taking out 1/3. Now I'm going to have more. I had more than that before I took out the money. So I want to find out how much was in it before I took out the money. So I really can't get at this directly, but if I know that 2/3 is 250, half of that would be 1/3, which would be 125. And then 3 of those would be 3 times 125, which is 375. So it's kind of nice with number lines because you can visualize it. But in just 2 steps, it's going to be 250 divided by 2 times 3. So that's how you could do it with an expression. Problem 7 in your homework. Each blueberry bush this year produced an average of 10 pounds of blueberries. This is 5/8 of their normal production. How many pounds do they normally produce? Okay, so the main issue here is for you to understand, is the answer going to be greater than, less than, or equal to 10 pounds? Is it going to be less than or greater than? The answer, like the answer right here. You need to think about that, because if you can understand that, then this is really pretty easy. And if you answered it's going to be greater than 10 pounds, good job, because it is going to be greater. 10 pounds is only 5/8 their normal production. So their normal production would be 8/8. And 5/8 of a number. So I'm just going to do this the way I would do it. I would say this is 10 times 8/5 which is 16 pounds. So that's the answer. Sometimes in high school, maybe they told you to use algebra on a problem like this, which would be 10 pounds equals 5/8 of their normal production. We don't know what their normal production is, so we use X. Multiply both sides by 8/5, which is the reciprocal, and we're back to 16 pounds. And we could also do it with number lines, right? I think visually number lines will give us our best way of visualizing what's going on. So here I'm going to start with 0, and I'm going to have their normal production. We don't know what that is. Normal, and we don't know how many pounds that is. And here we're going to have, we know that 10 pounds is 5/8. And that's 8/8 because that's their normal production. That's the whole. So I'm going to put in 0, 1, 2, 3, 4, 5, 6, 7, 8. So I have 5/8 is 10 pounds. I want to find out what their normal production is, which would be 8/8. So if 5/8 is 10 pounds, I can find 1/8. Divide 5 by 5, I get 1. Divide 10 by 5, I get 2. So 1/8 of their normal production is 2 pounds. And we know that the whole is 8/8. So I'm going to multiply the 2 pounds by 8, and I'm going to get 16 pounds. So that's 7. I think the easiest way to do it is to recognize if you need a bigger number for an answer, you're going to have to multiply this number by something greater than 1. If you want a smaller number for the answer, then you would multiply this number by something less than 1. So your choices really are going to be 5/8 times 10 or 10 times 8/5. And if you can recognize that, you would pick that. So students often have problems with word problems or application problems like this. So I'm going to try to go through this. This is number 9. This is you have 3.5 cords of wood, and you're going to divide it equally among 5 neighbors. How much would each neighbor receive? Well, first of all, yes, this is 3.5 divided by 5. That's what it is. Or you can also write it like this, 3.5 divided by 5. Because that's what you're doing. However, dividing by 5 is the same thing as multiplying by 1/5. And this is going to be a lot easier to accomplish. So remember, we've been over this a few times now. Dividing by 5 is the same thing as multiplying by 1/5. Taking some arbitrary number and dividing by 8, say 16 divided by 8, is the same thing as taking 16 and multiplying it by 1/8. Taking some other number like 30 and dividing it by 10 is the same thing as taking 30 and multiplying it by 1/10. So this understanding is pretty crucial here. Now I'm going to change this into a fraction. So that would be 7/2 times 1/5. You multiply straight across, and you get 7/10 of a cord. So each neighbor gets 7/10 of a cord. And that's really the way to do that problem. All right, I just want to do a couple of these on problem 10. Students often have trouble with these kind of problems, just multiplying a whole number times a mixed number. So I could change this into a fraction, but I'm going to do it using the distributive property. Understanding that 2 2/3 is put together with addition, right? Because it's a different place value. It's the remainder, the fractional place value, sort of. Then I can multiply 3 times 2 and get 6, plus 3 times 2/3. Notice the 3's cancel, and I get 2. So the answer is 8. And if you get halfway decent at these, you can do them in your head. This one I'm going to kind of do in my head. This is 10 times 2 plus 10 times 2/5, which I can reduce this to 2 over 1. Multiply straight across, I get 4. So the answer here is 24. The problem comes in, if you want to change them into fractions, what about doing this? 10 times 100 and 1/5. Gets ugly to do this as a fraction, but I can do this simply. 10 times 100 is 1,000, plus 10 times 1/5 is 2, so it's 1,002. Okay, problem 11, and I did this one just to review some basic little algebra problems. Using the reciprocal, right? I could divide by 3/4, but 7 divided by 3/4, which is what I wind up with on this side, is convoluted, right? So I'm going to use the reciprocal. Multiply this side by 4/3, multiply this side by 4/3. These cancel because a number times its reciprocal is 1, so I get x is multiplied straight across, 28 over 3. This one here, I could use the reciprocal immediately, multiply both sides by 6/5. But then I would have to multiply this by 6/5 and this by 6/5. So it's an extra step involved if I do that first. If I just subtract 4 from both sides, I get 5, 6 times x equals 3. Multiply both sides by 6/5. And I get x is 18 over 5. If you love mixed numbers, that would be 3 3/5. Now I'm going to multiply by the reciprocal, but you have to recall that a negative times a negative is a positive. So I want a positive one. So here on this side I now get x, and on this side I get negative 10 over 8. Or you could get 10 over negative 8. Or you could just write it as negative 10/8. All these here are equivalent.